Gracias, David. Thank you, David. So, yes, my name is Luis Majano. I'm the CEO of Virtus Solutions. I'm a computer engineer by trade. I was born in El Salvador. I was imported into the US since very little. I pretty much lived all my life in the US. And I moved here to Malaga about a year and a half ago, so I'm a boquerón in progress. I don't know for how long, but I'm here. So we're trying to expand here in Europe, so we're opening offices here in Europe. So today I'm going to be talking about BoxLang. BoxLang is a new dynamic language for the JVM. We announced it about 4 weeks ago in our conference in Washington, D.C. We're in open beta right now, and we're going to talk a little bit about it. So what is BoxLang? So BoxLang is a new language and runtime for the JVM, inspired by a polyglot team. The majority of people at Ortus can work with many different languages, over 5 per person. We've been doing this for quite a while. We're in open beta, and we're expecting a stable release in fall. It is a full scripting language, but it's also a templating language. It is dynamic with an optional type system, using pretty much every single modern Java interop, and trying to focus a lot of removing verbosity and removing all limitations in terms of Java interop for a dynamic language. Highly functional. We really have been doing functional programming for a long time, especially using Clojure and CFML, Cold Fusion. And we also wanted to bring to the language our application frameworks history that we've been developing. So it has many application concerns, from caching to events to task scheduling, synchronous computations, etc. It is very small, very lightweight and modular, as we'll start discovering, and can reuse pretty much any Java library or Cold Fusion CFML library deployed from the past 25 years. And a big focus for us was that it would be easy to learn. Now, we didn't wake up one day and say we want to create a language. At Ortus Solutions, we are a professional open source company. We created this in 2006 in the US. And we pretty much, over the last 18 years, created the majority of frameworks and libraries for the Cold Fusion ecosystem, from package management to CLIs to MVC frameworks to testing frameworks, etc. We manage over 300 libraries in our portfolio and over 18 years of servicing different communities all over the world. And we have 3 branches, one in the US, one in El Salvador for Latin America, and now here in Europe, based here in Malaga, in Spain. And there were many reasons of why to create this language. Like I said, I didn't wake up one day and said, hey, I'm going to build a language today. We're not that crazy. Well, maybe a little to delve into this area, but not a lot. But it was really more of a culmination of the 18 years that we've been developing open source. We could not continue to innovate and create what we wanted or what the engineering team wanted to create based on the current language vendors of Cold Fusion specifically. And we really needed a way forward for the entire engineering team and for us to migrate all of our clients to move forward. So in the dynamic languages space, there really has not been an evolution or something new since the past 15 years. So we really wanted to focus on how we could bring freshness into the dynamic language space. And we really produce a language of the times. Today is not the same as 15 years ago, 20 years ago, 25 years ago. So we started with several goals and vision of what this would look like, right? We wanted it to be dynamic, of course. We love dynamic languages. Modular, we create a lot of modular hierarchical frameworks, so we had that experience. We wanted to bring it forward. We needed it to be lightweight and fast. The current implementations, for example, of Adobe Cold Fusion or the open source versions are over 600 megabytes. They're huge, and they can get all the way up to a gigabyte for the language itself. We needed to be 100% interoperable with Java. We needed Java developers to be part of this, and we needed every single Java library to be available. We wanted to be modern, we wanted to be functional, and we wanted to be fluent. And especially at Ortus, we have been working with so many languages, we kind of took the best of all of them and mixing them into what we believe is a great concern for programming. Modularity was very important for us. We wanted to create a very small core and then build an entire ecosystem like we did with our frameworks. Take advantage of the full JVM, how modern it is today. Also fully tested. We wanted to make sure that everything is tested and be able to support multiple runtimes. This was also very important for our clients. We really wanted to deploy this to watches, to Android phones, to iOS phones, right, to Lambdas, to anything that happens to exist now or beyond. We needed to have that capability. We also have multiple transpilers, as we will talk a little bit about it. So we can actually, inside of our own parser, we have multiple parsers to parse different languages into our runtime. And this was important for all the applications that we built. We didn't want to change one single line of code. We wanted to all execute within our runtime. We also wanted tooling. This was very important. This is where a lot of the dynamic languages lacked, which is not very good tooling. And of course, compete in today's language environments. So I'll take you a little bit through the features of what BoxLang is composed of and through the semantics. The first one, which is the most important for us when we designed this, is to have a multi-runtime architecture. We really wanted to focus on small and very compact and lightweight. So we started at bare metal. We wanted to target this to the barest of them all, just to execute on a CPU, whether it's ARM, Intel, or whatever. And that basically gave us a full language at 6 megabytes. It is completely tiny. With all the dependencies, it runs and clocks at 6. And then we said, okay, we needed to deploy to different environments that our clients are already deploying now. So we created Docker images for this as well. So you have a full Docker image of the CLI component, but also we created a mini server, a full Java implementation for a web server. And then we create also a servlet container called command box. So we created another runtime so we could deploy in a more robust servlet container. But then we also targeted other servlet containers, okay, that implement the Jakarta specs. And then we said, okay, we need Lambdas. So we focused on the Lambda runtimes to be able to execute Lambda functions in AWS. And the next three are coming. They're in development, as I'll show you. But they're all very, very tiny, okay? We're also working on Azure Functions. We're also working on an Android SDK, so you can actually develop for Android applications, and WebAssembly, and, oh, you can barely read it, but it says WebAssembly. WebAssembly. And iOS as well. So this was really important for us. We needed to start from the bare minimum and then basically start decorating depending on where we deploy. To give you an example how we built our Lambda runtime, we created the Lambda runtime, and then we created our first production application, which is called try.boxlang.io. You can actually go in your phone, and it'll open up this editor, and you can actually code in BoxLang and execute, and we're going to be creating lots of sharing capabilities, abilities for you to actually create your spaces and code. But this was really important for us because it was a true testament that what we had built worked like we wanted. So it's an internet playground to code. Okay? This was our first production application at Ortus. It's powered by Lambda runtimes. It's going to be skinnable, and it's going to be embeddable on any site. So you're going to be able to create snippets of code and put them wherever you want. And mostly we're creating them for documentation. And how it works is that we have the mini server site as a microservice deployed in our cloud. We actually have an AWS load balancer, and we have 3 Lambdas load balanced on demand. And then we actually execute the BoxLang source. So the mini server uses 64 megabytes of RAM. It's about 600 kilobytes. It's tiny. It's fast. Our Lambdas are 6 megabytes each. That's with all the source code that we added on top of our runtime. So when you actually code the mini server site and you send your code through, it goes through the Amazon load balancers. It hits one Lambda, whether it's alive or dead, because Lambdas can die and go up and down as you see fit. It will actually compile your code and then send it to our executor to execute the code, all within the Lambda, and then basically send it back to you to see the results. So it's 2 microservices all working, one from one cloud to another cloud. Okay? And this was a real testament of how we started implementing multi-runtime for BoxLang. So, and this was really important for our customers that had never been able to do this in other languages. And it means that every request can fire up its own lambdas, okay? It also means that we never have to worry about how many instances we have. We don't have to worry about queuing. We don't have to worry about bad actors accessing other people's files. They're ephemeral. We can easily update our Lambda runtime, and all the instances are running all of our new code instantaneously. The Lambdas can also have tiers, so we have different staging environments, testing environments, and we can scale up as big as small. So this was a first testament of saying, okay, what we're doing will benefit the majority of our customers as it's benefiting us. The next section I want to show you is a little bit about language semantics. And I'm not going to compare if statements or for loops or how to create stuff, because the majority of languages, believe it or not, they're all the same. They have the same constructs. The differences come in terms of making you even more productive or fluent. So we support 3 file types: BX, which are classes, okay? These are going to be your classes. BXS, which are scripts. Remember, we can script at the operating system level, or we can script also at the language level, because we also have a templating language, okay? This is inspired by Confusion. So let's start with scopes. Scopes are very unique to BoxLang. And this is where all variables are stored in a page of execution. All variables are stored inside of what we call scopes. Okay? All scopes are backed by Java concurrent maps. Okay? And each execution context have different scopes. So for example, a script only has variable scopes. A function has an argument scope that comes in, a local scope that's only available to the function, and any surrounding scope of where the function lives. Then we have classes. Classes can have 3 different types of scopes. It can have a this scope, which is public, a variable scope, which is private, and a static scope, which is static, right? It's based on the blueprint of the class, right? And then we also have global scopes to help you as developers. We have an application scope that we'll talk about. It actually can create virtual applications for you. It has a request scope, so it simulates an incoming request to your language, right? It'll give you a scope that only lasts for that request, server and session as well, and more that you can create. But to start off here, you can see that you basically just declare a variable and assign it. You don't have to specify a type, right? I don't have to specify any semicolons. It's super easy. I just declare the name, and there we go. If you look at functions, functions also take in arguments. I don't have to specify anything. I can just say, here, it takes a name, and I can use that name. I can also use the var keyword. The var keyword basically puts all the variables inside of a local scope inside of functions. So it's only available to the local function. But scopes are also available to you as objects. So here, for example, I've created a getMemento function. I look at the variable scope and I say, look at all the variables, and I want to filter them by key value. So I can operate on scopes. Okay? So this is important. Not only can I store variables in scopes, I can actually have access to those scopes. Okay? You can do more funky things as well here. For example, I can pass a scope around. So I can say, here are all my arguments. Go do something with them. Okay? So very, very different. Let's talk about types. So types, all the Java types are available to you. So everything in Java is available. However, we've enhanced a few of them. For example, arrays with a lot of fluent and human functions. We have structures, which basically are maps, but case insensitive. If you want case sensitivity, you can. They can be ordered, they can be weak, soft, etc. We also have a term called queries, which is specifically dealing with JDBC connections. Okay? They give you typed columns if you need to. We have our own date-time objects based on the new API in Java for Java time. Numerics, and this was important, in BoxLang, you don't really have to specify if it's a float, a short, a long, a decimal, a big decimal. It's a numeric. And then we'll figure out the semantics of it. Okay? XML, we also provided an XML type as well, which is a version of enhanced maps. They're all auto-castable. That means that we'll detect when you're sending it to a function that accepts long, but you send a double, we'll transform it for you. Okay? It's all supposed to be dynamic and functional and fluent. So you can see here, for example, I declare an array just like this. So I say fruits equals an array. Okay? That is an assignment. I don't have to specify that it's an array. By the value, I infer it. I can even print it by saying, okay, give me the length of the fruits. But I can get more functional. I can say, okay, fruits, I want to append a new fruit. Then I want to filter. You can see I'm using lambdas to even define how those fruits are going to be assigned. And then for each fruit, I can print it. And then I can even convert that fruit to JSON. And that was important. JSON is always available to you. There's nothing magical to do. Every type is convertible to JSON. Okay? You can even do literal notation. So for example, here is apples, bananas, and pears, which is a string literal, right? It's just a string. And then on the string, I can say, okay, convert this list to an array, then filter it and print it. So you have those capabilities. You also have more functional capabilities. For example, here I have a person structure. See, I don't have any verbosity or ceremony to create a map. I just basically say squiggly marks, I'm going to create a map. I give it a key, and I give it a value. Key, value, key, value. I can even then add other things by just dereferencing it. So I can say person.fullname, which doesn't exist here. I'm going to assign a lambda to it. Actually, this is a closure. So dynamically, you can add even functions to maps right there. And then I can even execute the closure right there. So you have all these capabilities for you to work with a language that if you wanted to do this in Java, I don't even know how many lines of code you need in order to do that. All right, functions. We've also added a lot of different things for functions. First of all functions are public by default. You can see here, here's a Java example, public int sum, right? In BoxLang, I just say function and give it a name. Okay? All the return types are any by default. Okay? We'll figure out what you meant when you return the value at runtime. All the arguments don't have types if you don't want to. They're optional. Okay? And then the question is, what is any? Right? Any can be anything. Well, we try to infer it. Right? We can do compile time inference. So by compiling your code, we can infer what you meant. Or we can also do runtime inference, okay? And it can change. It can be fluid. One type can move from another type as well. And then we do all that auto-casting for you. You don't have to do it. We can promote the types, so they can actually promote, for example, from long to double. Or we can do type coercion, where we can go down from double to int, for example. Okay? So you can see here that when we define the BoxLang function, we just say, here's at A, here's B, and then I return it. If I want to be more specific, I can say, okay, this is going to return a numeric. I'm expecting numerics. Or this could be int, or it could be double. All depends on what you want. And here, for example, here's numeric, and here's int. Okay? So you have those capabilities. Okay? Now, what about arguments? Well, here's another Java example. You have public void repeat. You have a string, you have an int, and a separator. And you have to call them all with all that data. If I wanted just another method with just string and count, I would have to overload it, right? And if I wanted just another one with just one, I would do another overload, okay? However, in BoxLang, you can have default arguments, okay? You've seen this in Kotlin, for example, or other languages in CFML. It's the same theory. You can actually create defaults, okay? So I can basically call my method with defaults, okay? But we took it a step further, and not only can you call a method with default arguments, but you can do argument binding, okay? And you can actually call a method with a special argument called argument collection. And if you say argument collection, then you tell it which map or which collection holds all your arguments, and we'll pass them through, and we'll try to bind them one by one, either by position or by name, okay? So the binding can work on any collection. That means it can be a struct or it can be an array. So it gives you that advanced capabilities that you can't do that in Java. Right, more differences. Function variables. Okay? So there is no need to say basically var like in JavaScript, right? You basically can just say B, and it will automatically inject it into the local scope. Okay? We infer the variable types. We can create very nicely literals, right? So here's an example of creating hash maps and array lists. Okay? You can also create ordered maps by using the array notation. So that means that it will create that map in an ordered fashion. Okay? And there's more little developer, I would say, nuggets available to make your life easier. We also have reassignments. This is something that, of course, Java does not allow, right? Once you define that Java type, you basically are stuck with that type. For us, it doesn't really matter, right? You can start with a numeric and then change it to a string. Our tools also give you insight into this and say, hey, why are you doing this? Or do you really mean to do this, right? Which is something important. You can also mark things as final. So that means that you are basically saying this cannot change or cannot be reassigned. Okay? So little updates here to make your life easier when working with variables. Another major difference is casting. Casting is so important in Java when you're getting things, especially from maps, unless you do generics, right? But the idea in BoxLang is to provide that auto-casting detection for you. So we'll kind of poke things around and say, hey, are you a string? Or hey, are you a double, right? And try to help you basically get information out of your code. Okay? You can also have the cast as operator. So not only do you use the Java approach of providing, a prefix to cast, but you can actually have an expression to cast. So you can say, hey, I want to convert this to 4, cast it as long. Okay? So it gives you nice little things just to make you more productive. Another one is immutability and mutability, and this was important for us for asynchronous programming. You can very easily call on any type to immutable, and that will basically seal that type, make it immutable. You can process it here, for example, in a synchronous function, and then when you're ready to do more things with that collection, you can say, hey, now I want it to become mutable. And then you can just say to mutable, and it becomes a mutable array at this point. And this is available for arrays, queries, structs, and more coming soon. We have other constructs. In this example is the null coalescence operator, or usually called the Elvis operator, because it looks like Elvis's hair if you look at it sideways. And this allows you to basically run any falsy expression, and the entire left-hand side of the expression of the Elvis operator will be evaluated if it's falsy or null. And if it's falsy or null, then it will return the right expression. Okay? So this is not the same as the ternary expressions. This is basically a coalescing expression. Okay? So imagine in Java, if I needed to get the length, I need to check if it's not null, return the string, or return 0. Okay? In BoxLang, I basically just say, hey, whatever this expression, if this expression is false or falsy or null, then return 0. Okay? So it'll shorten your code considerably. String interpolation has been a real power in, for example, CFML for a long time, and we've even taken it further in BoxLang. It basically allows you to do, obviously not string concatenation, because that's slow. Strings are immutable in most languages. In BoxLang, for example, you can just say, I want to return a string, open a string, and as you can see, you can use the hashes to interpolate. Okay? And that could be variables. But the hashes also allow you to do expressions. So just like, for example, in Vue.js, who here has done Vue.js or Angular, things of that nature, okay? So you can do expressions within it's the same. You can basically do expressions, do whatever you want inside of those hashes. They will be evaluated. So, but we also introduced the 3 quotes to create big strings. So here, for example, I've created a template, okay? So I do the 3 quotes, and then anything inside of those 3 quotes will be treated as a big string, and then I can do interpolation inside. I can call functions, I can do whatever I need, okay? We also have the capability to do binding very easily. So if we mix now with this template with the scopes that I was talking to you about, I've created a map of tokens, and then I say, go build a template, and here's an argument collection with my map. And here's the build template, but you see, I didn't even define any arguments. So in BoxLang, you don't have to define arguments. They will be treated as whatever you passed. So right here, I passed a map. So inside of my actual build template, I'm going to get these as arguments. That's why I can use them here. So it tries to infer those things for you, and it says, okay, you gave me a map for arguments, I'll treat them as arguments. Okay? So it gives you that quality of life for you to work with. Closures and lambdas and user-defined functions is something important in our language. Not only do we have closures, which are context-aware, so that means that when you define a closure with this arrow, the big arrow or the fat arrow, it basically will intercept the entire context, so all the variables, all the functions, everything around it, and it will basically have it available for you forever. Okay? We've also introduced the concept of pure functions or actual lambdas. The lambdas have no access to the outside world. They basically just have access to the incoming arguments and to the result. Okay? Great for performance, great for asynchronous computations. There's no side effects. Okay? And you can pass them around. Okay? So here, for example, I've created a function called toString. Okay? I can basically override it with another variable, okay, another function. So you can override functions at runtime. You can inject functions at runtime. Okay? You can return functions from functions. Okay? And you can create very fluent approaches to dealing with functional programming. I can say I want to run an asynchronous computation, and then when you get the result, compute more work. When you get that result, send the order, for example. So you can create all these nice fluent approaches to your programming. All right, classes. Let's look at a little bit of what we've done with classes. So here's a Java class. You can see here's public, class, user, 3 properties. Here's one constructor. Okay? But if I actually want to be a good Java developer, I need to add more things, right? Like all my nice getters and setters and right, maybe more constructors. But you know, what about hash code or equals and a bunch of other stuff? Dang. Now I wrote 53 lines of code for one simple function, right? And I know, you know, Java has done a great job in creating records and giving you these capabilities as well, right? So when you do Java, you end up basically building a lot of stuff manually, right? So in BoxLang, for example, classes are not verbose. We actually have the class operator, but you don't have to pass a name. The name of the file will be the name, okay? You have automatic constructors, so we'll basically analyze your properties and create automatic constructors for you. You can create your own constructor, but we'll do it for you. It'll automatically create toString, equals, and hash code. It'll also automatically create those getters and setters for all those properties. You can even mark that you shouldn't create a setter for a specific property. Okay? Automatic to JSON. So for example, in BoxLang, any class can have member methods. So these are methods that don't exist inside of this class that a framework author, for example, can give you. And we give you one called toJSON, because every type can be converted to JSON. So right now, I can say, I want a new person with this information, and then print the first name, and then convert the person to JSON. That's all my code, right? And for JSON serialization, you have a lot of tooling. You can exclude properties, you can include properties, you can add your own mappers, a bunch of stuff. Okay? But the idea is that we wanted to make it fully functional and fluent. Okay? We also do a lot of metaprogramming from ColdFusion and Groovy and Ruby, and we brought that as well into BoxLang. You have available this in any object. So any object inside of BoxLang, you have a special variable called $bx. Okay? So here's a person, for example, that I just created in the last slide. I can say person.$bx. That gives me access to metaprogramming. And then I can say, okay, to the bx object, give me the metadata about that class. It'll tell you how many properties it has, how many functions, its visibility, where it's stored, etc. I can also say, give me the class representation in Java, because this compiles to Java bytecode, right? So then I can actually have access to that class. Okay? But you can do more things. You can actually register change listeners. So immediately I create a class here called class with a property called important data. And then, remember, I have access to the scopes. So I say to the scope, variables, bx, I want to register a change listener for this key called important data, And whenever this changes, execute my closure. So right here, basically, I registered the change listener. I'll receive the key, the new value, and the old value. And then, for example, I can say clear the cache whenever these values change. Just like that. You can register change listeners for pretty much every object in a language. Here's another map. I've declared a structure here called my map. I can also register a change listener, but this time around, I didn't give it a key. I said, I want to listen to every key. And right there, I have a listener now listening to every key that you input, remove, or modify in this map. Okay. So metadata programming is first class in the language. Now, the templating language is also important. This came from the Cold Fusion days. Cold Fusion actually got it really, really well for a long time. They basically mixed JSP and Blade from PHP and Cold Fusion, and we've kind of taken the best of all those worlds, and you basically have a nice way to actually do templating. You have this nice BX : and then the name of an actual descriptor. So in this case, I say I want to produce some output. Here's some tables. Here's my hash interpolation. Here is a loop over an array and an item. Here I'm encoding already for HTML. Okay, another loop with an item, with another loop. So it's really nice, and now you can create your own BX tags. So if you actually want to create your own tagging language, you can. You can nest them, you can do data encapsulation, you can call BIFs, etc. So you have a lot of power in the templating framework. Here's even more templates. You can see I'm importing Java classes right here into my template very easily with a CF import, with a BX import. And then I can basically even run full expressions, do encoding, do interpolation, and I have a nice server language to template. Okay. But we took it a step further, and we said, okay, templating language is great, but what if I'm inside of my service and I need some type of template in order for me to send an email, for example, or an error log or whatever? So we created tag guidelines. So tag guidelines allows you to basically leverage 3 of these little ticks, and then when you're in script of the template of the language, you can actually move into templating. So here I've created a for loop on a collection, and I've created my tag island, and I've created my template, and this template will execute within the script. So now I'm mixing both parsers and both concerns within the same language. Okay? And this allows me to create a nice little template that I can iterate with different items for collection. I can even store all this in a variable and send it off on an email or whatever. So it gives you that power for you to template whatever you want to do templating. All right, so those were a little bit of semantics. The rest is like a traditional normal language. Then we focused on what we call the BoxLang framework, which is, we've been building frameworks. We wanted to give you the capability to extend your code. So this is the BoxLang framework right now. It allows you to create virtual applications that I'll discuss what they are. So it means that you can create mini applications inside of mini deployments. A lot of asynchronous services, so we tap into the concurrency of Java. Caching services to provide developers with nice caches. A component service so they can actually build their own templating language. Data sources will manage all the database connections for you. You can just register whatever JDBC driver you want. We've created over 10 of them. You can create your own functions that are global to the language. Events that you can register and announce. And you can extend the language itself via modules. And of course, we needed scheduling. And this was important for all the apps that we built. So we also created different scheduling services. To start off, the enterprise caching engine we built almost 10 years ago, and we migrated it now to BoxLang. And it allows you to basically have an enterprise cache available to you that it's extensible. You can have different providers, so you can connect it to different other cache engines if you wanted to, or use ours. Your code will always look like BoxLang code, but it can talk to many different providers without you changing a single line of code. So it's called a cache API or aggregator. It has different listeners, so when things are removed, etc. It has statistics for you, even graphing of how the cache performance is doing. And then you have different object stores for our own cache to store things in different types of object pools. So we take all that hard work and just give you a nice API for you to work with. The application framework is also really unique. It started in the Cold Fusion days, and what it allows you to do is that it's inspired by Java contexts. And before, it allowed you to basically deploy multiple applications in one Java server. In BoxLang, there could not even be a server, right? But it allows you to create these infinite segregated applications just by creating one file. And that file is called application.bx. This is a class, and within it, you have different lifecycle methods. So anything where that file exists down in the directory structure will be treated as one application. And it can have different listeners for when things happen, data sources, different jar files, different scopes, different security mechanisms. So it gives you nice abilities for you to create these mini applications that you can have portable and highly configurable. And this was really important for developers to be able to do this without a lot of them building this. Okay. This was another concern that we've had for clients for a long, long time. We actually created a scheduling framework for our MVC framework to allow you to do scheduled tasks that didn't suck, basically. Okay? Schedulers are created as classes. They are portable. They are written in a human approach and a fluent approach. They can be written in BoxLang or Java. It uses the completable future API in Java. And you have access to any executor, including virtual threads. And you can run them at the operating system level. You don't even need a server to execute schedules. You can create a script. If you're doing some type of scraping, you can build a little scheduler that basically is just calling your language and say scrape at this interval or whatever. And then you can create it right here. You can say, I want a task for scraping, call my module, whatever it is, every second. And when there's a failure, I want to listen to it. Or when there's success, I also want to listen to it. And you can even have a result of that task call. And it also will keep track of all those tasks for you. Okay? You can have one-off tasks. You can have disabled tasks. You can have tasks if you're in a multiple cluster environment and you connect the cache to it. You can say, hey, I want to connect the cache to this, and it will distribute the tasks across your cluster. Okay? There's importers that we're working on for Adobe and Lucy servers and maybe for other scheduling services. And we also have a task visualizer, so you can visualize all these tasks in a nice panel. Now, the important thing for us was, of course, Java, right? Java is our core. So Java 21 is our minimum, okay? So we're starting off with what's supported now. We also are fully JSR 223 compliance, which is basically giving you the ability to do scripting with dynamic languages in the Java virtual machine. You can actually talk to even other languages. The creator of one of our Clojure libraries, Sean Corfield, has even created already a bridge for BoxLang. It uses a lot of invoked dynamic semantics inside of Java. All the object-oriented constructs that you're used to in any language are available to you. Okay? And pretty much anything in the JDK 21 is available to you. That was important for us. Another aspect that was important for us is tooling. As developers, we need the right tools. So we have focused a lot on tools. And we've created two sets of tools. One is we've created an IDE based on Visual Studio Code, and we've created a lot of CLI tools. So to start with the IDE, you can start right now. This is available on the store, on the VS Code store. It's open source, free. And the BoxLang IDE gives you a full language debugger. The entire language server protocol that we've implemented is also implemented on BoxLang. So this is another runtime. So the entire language is inside of the editor. Okay? You don't even have to install a language. If you install this, you have the language. Okay? You can run classes just like Java or Kotlin, like say main. You can run scripts just by script files and run them. We actually created a place for you to run and manage your servers, your mini servers. Okay? You have code converters and code formaters, and we're working a lot to create a lot of code quality and visualizers for you, especially for a dynamic language. Okay? In the CLI tools, we've created a REPL, so you can actually test the code, just like we did in the cloud with the try BoxLang. You also have one in your operating system. We also have shebang support. So for those of you that are working in Unix, you can actually create a shebang script and basically say, my interpreter is BoxLang. And now you can script at the Unix level in BoxLang. You have ability to run files, run schedulers. If you have already Cohesion code, you can transpile it to BoxLang. You can compile. So you have, like Java C, you have the compiler. Feature audit also allows you to know what functions and components you're using in your code. And then a packager that we're working on in order to package your applications. That's coming soon. But to focus a little bit on the IDE, we really wanted a modern development flow. So these are real screenshots, it's real code. It builds entire outlines for you. It tries to even tell you if you're using the right dynamic types for you. A web servers panel, right? It works with a debugger. Here's, for example, the debugger. It'll tell you line by line, so you can basically start going, even if it's on a web server. Even if it's on a remote web server, we can actually connect our debugger to any mini server as well. So that was very important for us. Okay? And the language server was also important because it's open source. So if somebody wants to hack around and basically create their own versions of it, they can. It's extensible as well with modules, and it's really the foundation of all these tooling aspects that we built. Who here does Java a little bit? A little bit of Java? Okay. So the Java interop was really important for us. This was so Java developers can interact naturally, right? Not just basically lose everything they've learned, right? So it's basically part of the language, right? There's no separation here. We do the inference and the casting for you, right? But you can also import Java classes just like you're used to, right? You import, for example, javalang.system. You can even give them aliases, right? Here I'm mixing, right, languages. And then I say, okay, give me a new myDate, which is a Java util.date. Give me the time. I declare a number, an array. I can create copies of those arrays and print them. So we really wanted to make it seem very fresh for Java developers, so it makes it easier for them, but it also looks like Java. Okay? Here's a class that implements a Java interface. Okay? Now you'll see that there's a little Java colon right here. This is what we call object resolvers. So in BoxLang, we want the capability to mix different languages. So right now, we have a Java one. We actually created a module for Python. So you can be able to say here Python, and it will be able to talk to another Python class. Okay? Here's, for example, the run function that implements runnable, and very easy, you can create interfaces. Here's, for example, extending a Java class. Okay? I can just say, hey, I want to extend this class to a timer task in the JDK, and here are my two functions that I'm overriding in Java. Very easily. We also have the ability for you to execute those main functions just like you're used to in Kotlin or Groovy or Java. You have the same in BoxLang. As long as you have a function called main, it's executable from the operating system or anywhere you execute it from. Even modules have main classes. So a module can actually be a CLI module, for example. Okay. And you also have the capability to have annotations, just like in Java, but less verbose. There's no classes for annotations, and anything can be annotated in BoxLang. So here, for example, I've created a singleton annotation, okay, which there is no class called singleton that is an annotation. Doesn't matter. It's called metadata. So this metadata will be available for anybody. And the actual value of annotations can be literals, like a Boolean, or a string, or it can be nothing, right? Or it could be an array, it could be a struct, it could be, anything that's a literal is available to you. Okay? So you have all those capabilities to make your life easier. We're closing down here, I'll open for a few questions. This one was really important for us, and mostly because we built over 300 libraries in Cohesion code, and we didn't want to lose that. So what we did is that we basically, when we designed BoxLang, we knew that we wanted to parse multiple languages. This was important. So we created a multi-parser approach that it detects, depending on the file type, what type of language it is. In this case, if it's, for example, Cold Fusion language, it'll detect it, and it'll basically parse it into a BoxLang, what's called abstract syntax tree, or AST, and then it will take that AST that we call the BLAST and convert it into bytecode, okay? So this is a multi-step compiler as well. We also created for a client that basically their mandate was that it needed to be Java code to be deployed to their Java servers, for example. So we created a transpiler here from BoxLang code into Java source. So even from the IDE, you can say, I want to create a Java class out of this BoxLang class, and it will create it for you. So you have a lot of capabilities. Now, this has given us a really, really important approach to create things from one language into ours, using the BLAST. And we are now almost complete with this language, and we're going to move on to the next one, which is Groovy. So we're going to be able to take Groovy code and basically transpile it into our BLAST, and then if you have some type of Groovy languages or classes, they're going to be able to be transpiled into BoxLang. Now, it all depends on what third-party stuff you use, right? But mostly the Groovy applications use whatever's in Java, they will be able to be transpiled. And the BLAST was really important for us because this had never existed in the languages that we dealt with. And not a lot of languages give you the AST basically available to you. Actually, the metadata that we talked about, the BX, it has the AST representation in JSON available to you. So if you're a developer that wants to create code quality or see how that code was basically typed, you can. So you can do all kinds of things with the BLAST, from code quality to getting metadata out of your information. Okay? So we really focused on making sure that developers had access to the BLAST. Another feature important for developers that would separate the language is event-driven programming. And this was important. We needed the capability for the language to produce events, developers to register those events, and consume them. So just a typical observer-listener pattern. Okay? And this is core. You have the ability to create interceptors for the entire language, okay, for a specific application, or for even a request. Okay? And it's really the best way to scale pretty much any application. It's one of the most extensible design patterns in any language. Okay? And you can listen right now to any specific lifecycle of BoxLang. Okay? And the module developers can listen and collaborate these events. And this was important for us. Okay? You can also announce events on your own. So you can say announce, box announce. You announce an event. You can even say box announce async, and it will give you a completable future. Okay? And then you can actually deal with basically the result of that computation whenever you want. And here's an example here to announce an event. I basically say, runtime, I want you to announce an event, and I'm passing a structure of information, which is the data. Okay? There is no response, because these are asynchronous. They are just sent. Okay? And then here, for example, I have a listener. This one is in Java, and this one is in BoxLang. This one's listening to the on-server scope creation. Whenever the server scope's created, it will be announced. It receives the server scope, and, for example, puts some data in the scope. Okay? So this is really flexible for developers. You don't have to build all this on your own. It's there for you. And this was mostly important for us doing professional open source, is that everything had to be tested. We actually have more tests than commits, which is unusual. But we're really advocates, especially since we built the testing frameworks, we better test our stuff. Okay? And we also have it fully documented, which was another important thing. We generate as much docs as we can. We've already written a book called boxlang.ortusbooks.com. You can go to it, and everything is documented, and everything will be even more added as when we go to stable. Okay? And we're also creating the book in Spanish, by the way. So right now it's all in English, but there will be a Spanish version available as well. Okay? Now, here's an interesting part. If you're building Java, you can actually call BoxLang code from within Java very easily. You can create a runtime and say, runtime, I want you to execute the source. And it'll execute BoxLang source. It'll bind to an execution context, and then I can basically get variables out of it. So you can mix the languages. I can call BoxLang code from Java, or I can call Java from BoxLang code very easily, just by APIs. Okay. All right, last slides, and we're done. Then questions. The modules was really important for us. This is how we could expand. And this is where you as developers basically can collaborate. We really have various different needs nowadays than we did 10, 20, 30 years ago, right? Before, it was mostly web applications. Now you have tasking, you have queuing, you have scrapers, you have lambdas, you have CLIs, right? You have iOS, you have Android, you have WebAssembly. I don't even know what else is going to come in the future, right? So we have different paradigms that we need to address. And that's where modules, we really wanted to make sure that that's how we extend the language, so the core stays very small. So this is inspired because we've written a lot of frameworks. It gives you the ability to create a module with different collaborations. They can be written in Java or BoxLang or both. Okay? They can be executable from the CLI. They integrate with Maven or Gradle if you're using any type of Java tasking. But it allows you to basically collaborate built-in functions, tags or components, interceptions, different Java libraries, completely isolated, right? And even model objects, just objects you want to basically distribute to your users, okay? So we also have an ecosystem called ForgeBox that we've created for more than 15 years, and it's a website where you, as a developer, can register your own modules. It's open source, it's free, and then you can publish your modules there, right? All the modules that we've written right now are over 20. We have things for JDBC drivers, for different encryption algorithms, for Lambda, for mail, tons, okay? And then you can write your own, right? Here's where you can write your own things to share with people, right? And the good thing is that these modules also are isolated in terms of class loading. So when you generate or ingest a third-party Java library, it won't expose to the entire system. It is just encapsulated to your module. Okay? So we really want to foment that to third parties, and we're also going to be introducing e-commerce by hopefully this year, and this will allow you as the developer to sell your code. So it'll be just like an app store. It'll be basically a module store for you. You choose your own licenses, how you want to sell it, how you're going to get paid. Here's an example of basically creating a function that will be available for the entire language, right here. This is a BX class, remember we talked about? It has two annotations, one called boxBiff. This means that this is going to be a function, and this is the name of the function, module hello world. And then I can even create member functions, and I can say, box member, I want you to attach into strings any string that's defined in the language with a new function called foo. And for any array, I want you to create, oh, nothing. Well, the name will be this one, the name. So this means that you as a developer can create functions anywhere, right? And the function is just simple. It's one invoke, how many arguments you want, if they're required or not, if the type or not, and then whatever happens inside is your code, right? So as a developer, you can really basically start creating enhancements to the language very, very easily. Okay? This is how we created the Python module. So BoxLang is a fully JSR 223 compliant. It allows you to embed any Java-based language. There's a language, of course, I'm pretty sure familiar with, Python. There's a representation called Jython, so we created that module called Jython. And this allows you to script in Python right within BoxLang. It can actually execute Python classes, Python modules, get results, etc. And the entire module is like 300 kilobytes, super small, but it's super easy to start building these modules. And this is what we wanted. We really wanted to take control, finally, of our own runtime so you can actually extend the language as we see fit. Not as a vendor tells me to do it, is how we wanted to extend it. And we don't even want to dictate that. It will be up to you. So this is a an intro into the language. Hopefully this gives you an insight into what we've done. We've only been working on this for 8 months. Only 8 months part-time, because we still have a lot of clients. So we started with 4 developers. Now the team is 15 developers working on the language day in and day out. And it's really exciting to see where this is going to go. We're mostly building it for us. Like I said, we really wanted to get away from the big vendors and be able to take control. And hopefully we'll see next year all the different things that we come, and maybe somebody else comes and present things that they built in BoxLang. But maybe any questions, doubts, comments, jokes, riddles?
Hello, I have 2 questions. One, because it's so similar to Java, it has the same herency limitation of Java class?
The same one?
Herencia, la herencia de las
Herencias, yes. Yeah, it has inheritance, implementations,
But
everything.
the same limitation, or you have upgraded?
Oh, you mean like in Java, you can only do 1 level of inheritance? Just 1 level. I think if you want multiple levels of inheritance, you want more problems in your life. That's what I think.
Okay,
I think only C++ allows you to do multiple inheritance. I think C or C++. But I don't think it's a good idea, in my opinion, to do multi-level inheritance.
Okay.
There are ways that you can do it in BoxLang, actually, called virtual inheritance. Because remember, it's dynamic, right? So you can we actually do this in our framework for dependency injection called Wirebox. You can say basically, hey, here's my class, here's another class. Can you merge them for me? And it'll do it. So you have capabilities. Just be careful.
Thank you. And the second one, do you need to have installed Java in your equipment?
Yes. So for now, yes, you need JDK 21, right? Eventually, we're going to give you 1 binary, and then you won't need, we were trying to embed it, right? But that will come probably next year. But for today, you need to have Java installed, 21.
Okay. Thank you.
Any other questions? Curiosities? ¿No? ¿En español también? ¿Les pueden hacer en español? ¿En español? ¿O portugués? Como quieran. ¿No? Bueno. Gracias. Muy amables. Gracias.